Okay. The characteristic equation of a matrix is an equation. How to define the equation means, let us take this A be a n by n matrix. N by n matrix means a square matrix. Okay, and the characteristic equation of this matrix is determined by determinant of A minus lambda I equals to 0. Okay, here the matrix A is the given matrix, lambda is some constant, and then lambda is some variable, I is the identity matrix of the given order. We call this this determinant as a characteristic equation, and it has several properties. Okay, so here this determinant of A minus lambda I equal to 0 is a polynomial of nth degree. Polynomial of nth degree means what? Like it is of 3 by 3 order means we will be getting a cubic equation. 2 by 2 order means quadratic equation, like the general format. Okay, and then we will take some examples. Suppose if the order is 2 by 2, then we will be getting the matrix, so the equation, this lambda square minus some A lambda square, right? Some A lambda square minus some B lambda plus C is equal to 0. Okay, in this B is right, that B is equal to sum of all the eigenvalues. Sum of all the eigenvalues. No. That B is equal to sum of the diagonal elements. Which diagonal elements? The principal diagonal elements. Okay. And this C is nothing but determinant of the matrix. Okay. The same way, cubic, they have given something that we are the sum of all the determinants formed from a square matrix of R. No, don't bother. And then every square matrix satisfies its own characteristic equation. Every square matrix satisfies its own characteristic equation. What does it mean by satisfying? Suppose we get a square plus 3a plus 5i is equal to 0 means, here in place of a, we will calculate these values and we add means we will get 0 matrix. It is not 0. What we will get is 0 matrix of the same order. Okay, of the given order. And the other one, for cubic, suppose for this 3 by 3 matrix, this equation can be like lambda cube minus some beta 1 lambda square plus some beta 2 lambda, or let it be S1, S2, S3 man. Why beta 1, beta 2? S1, S2, S3 is equal to 0. Am I audible? Okay. See, these coefficients, right? As I told you before, this is the equation. Okay. In this equation, like here also we'll remove this A is not needed. Okay. So in this equation, this S1 is sum of the diagonal elements, right? Sum of diagonal elements, we call it a name. What name it is? Trace of A. S1 is trace of A. And S3 is same like determinant of A. That means the last coefficient. See, first coefficient is trace of A, last coefficient is determinant of A. This S2 is right, it is sum of minors of diagonal elements. Okay, it is sum of minors of diagonal elements. Alright, that is it. So this A minus lambda is equal to 0 is a characteristic equation, and for 2 by 2 we have this equation, for 3 by 3 we have this equation. That is it. Now we'll see one example. Shall I erase this? Say this is 3 minus 4 4, 1 minus 2 4, 1 minus 1 3. Okay, so we should find the characteristic equation. Like in both ways we have to find it. Okay, for the first question, just to give you an idea, that is it. Okay, so here this characteristic equation, right, see this is A minus lambda I is equal to 0 is the characteristic equation. Alright, so in this, now 3 minus lambda, like we will expand and write means what we will get, this determinant of 3 minus lambda minus 4 plus 4 1 minus 2 minus lambda 4 1 minus 1 3 minus lambda equals 0, right? Then we should take what determinant. Now let me take it along C1, because we have 1 and 1 here, and all 4 4 is the big number. Okay, what's that? What we can subtract? That like also you can do, but it takes time. Better we'll write, because there is a shortcut. I'm just explaining you how to do this. That is it, using the direct method. So this along C1 if I am taking means this is 3 minus lambda into this minus 2 minus lambda 4 1 3 minus lambda, and then see this is plus, this is minus, this is plus, right? And then plus, not plus, minus 1 into the minor of this element, that is minus 4 4 minus 1 3 minus lambda. Okay, and then plus 1 into again minor of this element, minus 4 plus 4 minus 2 minus lambda plus 4. Okay, that is equal to 0. Now calculate this determinant. 3 minus lambda into this is minus 2 minus lambda into 3 minus lambda minus 4, and minus 1 into this is minus 4 into 3 minus lambda, and this is plus 4, and plus 1 into again that last minus into minus, that minus 16, minus 4 into minus 2 minus lambda. Okay, alright, are you doing this? Are you noting down? That is equal to 0. Then 3 minus lambda into, when we multiply this, what we will get? This is minus 6 plus 2 lambda and minus 3 lambda plus lambda square minus 4, and minus 1 into 4 3s are minus 12 plus 4 lambda plus 4. Okay, and then plus this is minus 6 plus 8 plus 4 lambda equals 0. Any doubts in this? Now we'll get 3 minus lambda into, add them. Yes sir. Where sir? Into, is that plus 4? here. Yes. This minus 1 I left. That is plus 4. Then next step plus 4. That is it, right? Then minus 6 means this is minus 2. Alright, no problem. And then minus 1 into this is 4 lambda minus 8 and plus this is 4 lambda plus 2 equals 0. Now multiply them again inside. This 3 multiplied, you get 3 lambda square minus 3 lambda minus 6 minus lambda cube plus lambda square minus 2, not minus, plus 2 lambda, and then minus 4 lambda plus 8 plus 4 lambda plus 2 equals 0. Minus 4 lambda plus 4 lambda out. Now we'll group it. Then we'll get minus lambda cube. Lambda square means 3 lambda square plus lambda square. So we'll get 4 lambda square. And then lambdas and all, minus 3 lambda plus 2 lambda, which is minus lambda. Now minus 6 plus 2, which is minus 4 plus 4 equal to 0. See, minus 6 minus 6 plus 10, which is what? Plus 4. Now multiply with negative. We'll be getting lambda cube minus 4 lambda square plus lambda plus 6. Yes. Yes. Okay, this is how we should get the characteristic equation. But we have a shortcut. Have you noted down? We have a shortcut, man. What is the shortcut meant? Instead of doing like this, directly you can write the characteristic equation. The characteristic equation is lambda cube minus s1 lambda square plus s2 lambda minus s3 is equal to 0. As you observe, I started with the minus s1 square, s1 lambda square plus s2 s. Yes. That we worked out now this much longer. Directly you can use this. I just to tell you that is how we should work it out actually, but we are using the shortcut. Okay. So here S1 is what? Trace of A, and S2 is the sum of minors of trace of A. Sum of minors of trace of A. Okay. Elements in the trace are elements of the diagonal elements. Okay. And S3 is simply determinant of A. Now calculate these three values, substitute in the equation, everything will fall in place. Okay. So this S1 is what? Trace of A. Add these two. 3 minus 2 plus 3. So we'll get 6 minus 2, 4. S2 is sum of minors of trace, sum of minors of diagonal elements. So diagonal element diagonal elements minus you should add. So minus 2, 4, minus 1, 3 is the minor of this element. Okay, then for minus 2 we should write what is the minor of that element. For minus 2, that row, that column. Then we'll get 3, 4, 1, 3. Okay. See, we don't need to multiply the elements. Simply the minus we are calculating. It is not about calculating them. Okay. For the last diagonal elements, that means for this 3. So this is 3 minus 4, 1 minus 2. Do you have any doubts on this? How we written on this? So I wrote minus of this diagonal elements and I added those things. Okay. Now this is minus 6 plus 4 and plus this is 9 minus 4 plus this is minus 6 plus 4. Yes, minus 6 plus 4 again. Then we'll get what? This is minus 2 plus 5 and this is minus 2 again. So we'll get 1 as the answer, that is S2. And S3 is simply determinant of A. Determinant as usual we calculated, right? So 3 into that determinant value, this only will come minus 6 plus 4 and minus of minus plus 4 into, I am taking it along R1 first row, okay. Then minus 4 into the minor of that element is that row, that column, 1 3s are 3 minus 4 and plus 4 into this is minus 1 plus 2. I took the determinant as usual. So 3 into minus 2 plus 4 into 1, not minus 1 and plus 4 into 1. Okay. So we get minus 4 plus 4 cancel, we will get minus 6. So substitute in this equation, minus S1. S1 is what? We got 4 lambda square. S2 is what? We got 1 and S3 is minus 6. Minus of minus 6 will become plus 6. I think while multiplying we got plus 4 over there, is it? Somewhere. I might have committed some mistakes. Just go through. Okay. But this is the correct one. Okay. This is the characteristic equation. What is so special about this equation? The matrix, if you substitute in place of lambda, if you substitute the matrix, that matrix will satisfy this. That is what we say, yes sir. We got plus 4. Equation has minus S1 lambda square, right? See, the equation is lambda cube minus S1 lambda square plus S2 lambda minus S3 is equal to 0. Okay. Okay. Alright. Then what I was saying? This one. If you substitute our matrix A in there, see, we will be getting A cube minus 4A square plus A plus 6I equal to 0. You don't need to work it out. You just make sure it is a characteristic equation. And just like if you see one equation means equal to 0, directly you can put it. Okay. See, that is what we say, it is CAYLEY-Hamilton theorem. What CAYLEY-Hamilton theorem states is, every square matrix satisfies its own characteristic equation. It happens only for every square matrix. Alright. And look at this another example. See, if the matrix A is 2 minus 2, 2 and 3, and if we get A square minus 5A plus Ki is equal to 0, then we should find the matrix K. See, K value, the value of K. Okay. See, just retrace it. This is a, this is what characteristic equation of this matrix. Substituted in this. So this is of the form lambda square minus S1 lambda plus S2 is equal to 0. Okay. What is S2? That is our K. That is the determinant of 2 minus 2, 2 and 3. So we'll get 6 plus 4 is 10. That is the value of K. Okay. Any doubts on this? Because the given matrix is substituted here, we can confirm that it is the characteristic equation, okay, by this Cayley-Hamilton theorem. Alright. That is it. The same like questions are there. You try working this out, and then shall we go to the next topic? It's not submatrix. We should start with augmented matrix.